So why do we have inequalities? Let's take a look at the following situations. An inequality is used to describe situations where there is a range of solutions, not just one. Let's take a look at the following problem. Your bank account needs to be over $40. So what we'd like to be able to do is to translate this into a mathematical statement. So we're looking at our bank account, so I'm thinking for my variable I'm going to choose B to represent the bank account. And then our keywords here, over $40. Over meaning I can't just have exactly $40 in my bank account or anything less than that. It's got to be at least $40 and a penny, or $50, or $100, or $1 million. But as long as I'm over $40. So for that particular sentence, what I want to do is translate that to be as greater than $40. Alright, so now we've got from our sentence in English to mathematical statement. But what if I also want to visually see this? I want to see it as a graph. So let's make a number line. And you know what, since I have to go all the way up to 40, I'm just going to skip by 10s. We're going to start here at 0 and go by increments of 10, because that's a reasonable amount where I can still see the details of the graph. Okay, so now anything above $40 was going to be in this region over here. So like, 45, 50, like I said before, somewhere way out to the side, $1 million here, 100, but anything over here. So essentially we get a bunch of dots in a series where eventually it's just going to become one big long arrow. This represents everything above $40. But then we have a little problem here, because even though we know where this graph came from, what if we showed this graph to somebody else? Well, they might misinterpret this graph. They might misinterpret this graph as $40 or more, because to them this graph starts at 40 and goes up, even though we know we want this graph to start at $40.01 and go up. So how do we make that distinction between something that starts at 40 and goes up, or starts just above 40 but doesn't include 40? Well, the way we do that is we put a dot at the end, and depending on what that dot looks like, we can tell whether it starts exactly right there or just above it. So I'm going to erase a little bit here. And so what we want to do is we want to describe that we're starting just above 40, but not on 40. So the dot we're going to put is an open dot. That open dot represents the fact that we want the graph to start at 40, but not include 40 as its initial number. We want it to start off at $40.01. So when we want it to start above 40, we use an open dot, meaning we're starting at 40, but not including 40. If this had been the other situation in red here, we would have used a closed dot. All right, and that's how you create inequalities and graph them. In this example, we're going to tackle things in a slightly different manner, just to get a different perspective on things. We're first going to translate our situation into the visual graph, and then go to the inequality. So let's take a look at what we've got. The situation says you must be 7 feet tall or shorter to ride the coaster. So in this case, when I go to my graph, first off I need to reach up to 7, so let's do something like this. I'll grab a pen and go from 0 to 7. I don't think I need to skip increments, I can just go by ones. And then I think about what this graph would look like. It says I can be 7 feet tall, so this time I'm going to put a closed dot at 7, because it means that that exact 7-foot person can ride. Anybody taller? No, but the 7-foot person can. And then anybody shorter, meaning anything on this side of the number line. So I create an arrow going this direction. So we have the 7-foot tall person and anybody shorter. So again, notice how I did the dot though. The dot is a closed dot or a solid dot because what we're concerned about is this misunderstanding here. Is can that 7-foot person ride? In this case, yes. Now, let's say you had to have been shorter than 7 feet. Well then this wouldn't apply and you'd have to use an open dot. So that dot is really important. It's all about whether we're including our starting point as a part of our solutions or not. Now in this case we're including the 7-foot person, so it's a closed dot. Okay, so now let's take a look at the rest of it. Let's translate this to an inequality. And the way I always like to think of this is I always like to think of the graph as two different parts. We've got the dot, which indicates the 7-foot person. So the dot itself is representing the fact, let's say our variable is h for height. That is saying the height is for that person is exactly 7 feet. Then the arrow is telling us about all the people who are less than 7 feet. So when I come up with my final inequality, it's just a combination of these two inequalities, which is saying that the height has to be less than or equal to 7 feet.